Welcome to those of you who are new to this type of homework, and welcome back to those of you who got introduced to this last year. I want to remind you at this point that you need to get your notebook, and the other thing that you want to have handy, you pull it over here, your calculator. So get those. You can stop this and get your notebook if you haven't already got it there. Things we're going to talk about today. Well, this first unit we're going to do in 4 sections, radian and degree measure. I'm going to take my time with that to make sure that we get the right foundation under us before we get into the trig functions themselves. A lot of this is a review of your geometry, but we're going to learn some new ways of looking at angles. At least I think it may be new. Placing an angle into standard position, really, it's so simple. All it means is that your vertex is right here, your initial ray is here, and your terminal ray is somewhere on the coordinate plane, emanating from the origin. Measure angles in either degrees, which you are very familiar with, or radians, which you may or may not have been introduced to. They make a whole lot of sense, and we absolutely need them when we're doing certain kinds of measurements with angles. We'll talk about why later. Complementary and supplementary angles, well, you remember that. Complementary angles, for both of these, we're talking about pairs. Complementary, a pair of angles that add up to 90 degrees, and supplementary are a pair of angles that add up to 180. So we'll do a little work with that. Just make sure everybody's up to speed. Given the central angle, we know that would be something, let me change my color here. That would be an angle that's maybe lying here. Given the central angle, and when we talk about a central angle, do you remember from geometry? We're always talking about a circle. So we're talking about this angle. If we know the central angle and we know the radius, find the arc length. In order to find the arc length, we are definitely going to define that central angle in radians. And then finally, in the last 2 sections, we're going to be working on word problems which are about travel along a circular arc. It turns out that that's a very common problem that we have to solve. Because, for example, building roads, most of the time there's, at least here in New England, you find quite a few curves. Okay, how is an angle formed? Let's take a ray here. We've got one. Locate its endpoint. So the endpoint is the part that doesn't have an arrow on it. You can rotate this ray about its endpoint, and let's try doing that. So we can go, it looks like a clock. Can go all the way around, and we get all different angles this way. If I rotate all the way around, what would you tell me? I've made one full rotation. One full rotation. Let's try it again. One full rotation. What would you call one full rotation? I'm listening. That's right. In one full rotation, how many degrees have I traveled? $180, somebody's saying? No. How many degrees have I traveled? 180 would take me halfway around the circle. In a full rotation, oh, okay, most of you were saying that, 360 degrees. You can stop anywhere you like, you just get a different degree. The end position with its starting position form the angle. The end points of the rays is the vertex. I'm just getting that vocabulary back. Let's face it, it's been a while since you looked at geometry. Standard position for an angle. We keep the vertex at the origin. Standard position, by the way, always requires that you use a coordinate plane, an x-axis and a y-axis. We're going to refer to the measure of this angle as theta. This is a Greek letter. Perhaps you've encountered it already in science. If I want to show a positive angle, I'm going to rotate oh, wait a second here. Unlock. Sorry about this. I'm going to try ungrouping here too. Grouping. All right, I'm going to go back. I have to, I thought I was so ready. Well, I'm not. I was trying to rotate this like I did before. I'm going to do this actually with my pen this time. We have our initial side right here. If I want to describe a positive angle, I'm going to move counterclockwise. Counterclockwise, exactly the opposite of the way a clock moves its hands. And that will be counterclockwise. That will be a positive angle. If I want to describe a negative angle, I move clockwise. I start at that initial side and move down. This will be a negative angle. And this is moving clockwise.